This is the second page of that document, and it shows an enolate in action here. We're using the simplest example I can come up with. This is the 2-carbon aldehyde called ethanol, or acetaldehyde. And the first step there shows it forming the enolate. We're removing that one of the 3 hydrogens from this methyl group using a base like sodium hydroxide or something. And then here is that enolate just below in action. It's reacting with a fellow ethanol molecule. Now when we do that first step, we don't turn all of the neutral molecules into enolates. There's still plenty of neutral ethanol floating around. And so the enolates we have created, well, they will react with that neutral molecule that floats by. And you can see from these curvy arrows, the effect is to make a new carbon-carbon bond. And we temporarily have a negative charge up here on this oxygen by virtue of breaking that carbonyl bond. And the last step here just shows that negative charge on that oxygen recapturing a hydrogen here to make it an OH group. And so we've made a neutral aldol product here. Part aldehyde, part alcohol, so that's where we get the name aldol here. And you can see the systematic name for this would be numbering those carbons backwards. The fact that it's an aldehyde takes precedence over the fact that it's an alcohol, so that's why we number backwards. So that puts the OH at the 3 position, and you can notice this is named also with a suffix for an aldehyde, so it's a butanol that has a hydroxy group. So that's named as 3-hydroxybutanol. And there's other things you could continue to do with this molecule. There's still other reactions involving aldehydes that happen at the right-hand side of this, and we can do substitutions with that OH group. So this is a very versatile kind of reaction. It lets us quickly build bigger molecules from small ones, and then again we could do other things if we want to. But it's worth studying the details of this, because the only difference between this example and any other example I show you is we may start off with more than 2 carbons in our aldehyde, and as I'll show you in a little bit, we can sometimes do this with ketones as well. Right below that is the second simplest example I could come up with, using now a 3-carbon molecule, 3-carbon aldehyde. This would be propanol. And it's got these 2 alpha hydrogens. We only remove one of them, but we do have to remove the hydrogen from the carbon that's on that alpha position. If we were labeling here, we could say, well, this is the alpha position, these are the beta hydrogens, but we only are removing an alpha hydrogen. And so otherwise it's the same thing. Here is again a redraw of that enolate, showing those 2 electrons that are available to do some bonding, and so once again they couple with a neutral propanol, and we get a 6-carbon molecule from putting together 2 3-carbon molecules. Okay, and again the last reaction, the water that's floating around donates a hydrogen to neutralize this molecule. And you can see again the way we are naming this. It involves numbering backwards here, number 1 carbon, number 2, 3, 4, and 5. So this is named as a derivative of pentanol, and in fact 3-hydroxy-2-methyl-pentanol completes that name. So again, similar type of idea. We just have to pay attention to where those alpha hydrogens are when we're doing something like this.